But something else we hear far less about happened. The destruction caused by the earthquake in tsunami also released a half-century's worth of asbestos that was embedded in northeastern Japan's built environment, posing at least as significant a public health threat as radiation does. So despite the conservative moralizing about Japan's unforeseeable natural disaster, the destroyed buildings and piles of debris exposed the internal guts of Japan's built environment, including thousands of metric tons of asbestos imported from around the world. This, as I mentioned, may be the real public health legacy of Japan's triple disaster. Subsequent testing has found a host of asbestos minerals. The earthquake was certainly unforeseeable, that is, unforeseeable insofar as any earthquake in Japan is unforeseeable. But the destroyed buildings and piles of debris would release a decade's worth of asbestos that was anything but unforeseeable. Because Japan terminated the use of asbestos in 2005, asbestos is no longer out in the open, a blatant occupational hazard sickening factory workers or miners, as it did in Osaka or nearby Kanzaki. Now asbestos is deeply embedded in building materials, part of the composite stratigraphy of a past industrial age. For this reason, the place of asbestos in Japan's built environment becomes most clear when that environment is destroyed, pulverized, aerosolized, and then inhaled. It is after major disasters that asbestos can be monitored and measured, which gives some sense of the vast quantity of asbestos we continue to live with every day. Now, to be clear, the Great Eastern Japan earthquake was not the first time that asbestos was aerosolized and exposed victims, first responders, and others to dangerous levels of the miracle fiber. On January 17, 1995, the Great Hanshin-Awaji earthquake shook Kobe and the surrounding area for about 20 seconds, but with devastating results. The earthquake killed 6,434 people, most of them from the densely populated city of Kobe. Important for our discussion, the earthquake brought down some 150,000 buildings and a 1-kilometer section of the Hanshin Expressway. Embedded in this infrastructure, including acting as cement reinforcement, was half a century's worth of asbestos. Asbestos levels immediately after the earthquake are unknown, but as the demolition and cleanup began, the World Health Organization and Japan's Environment Ministry monitored air quality at several stations. The destruction caused by the Great Hanshin-Awaji earthquake released asbestos and significantly raised the ambient asbestos fiber levels around the city of Kobe. 2 months after the natural disaster, persistently high levels of ambient asbestos were detected at these monitoring stations. Now, just to give you a sense how asbestos fibers in the United States is true as well, but in Japan it's always true this way. What these represent of the number of fibers per liter of air. And the Japanese Environment Ministry only considers a fiber to be a fiber if it's over 5 microns in length. So if it says 16 fibers in 1 liter of air, that's 16 fibers, all of which are over 5 microns in length. Okay. So, and the Japan's Environment Ministry and the Environmental Protection Agency of the United States officially consider there to be no safe level of asbestos. So 0 is what the number is supposed to be, hypothetically. Okay. Now, obviously, in the midst of the disaster and immediately afterwards, the asbestos exposure risk became most elevated for earthquake survivors. The point is that the risk of asbestos exposure comes in waves. Occupational exposure when the fibrous mineral is mined, fabricated, and installed, and environmental exposure when the mineral is released through demolition and destruction. Now, the damage caused by the Great Eastern Japan earthquake of 2011 was far more widespread than the Hanshin-Awaji tragedy, far more widespread. Given the scope of the damage, the risk of asbestos exposure was also higher. 1 month after the 2011 disaster, Erica Buena, an asbestos analyst with EFA Laboratories, collected material for analysis from Sendai in Miyagi Prefecture. Quote, "I hope to find nothing, but I know it's there," he explained to reporters before he left. He later confirmed through polarized light microscopy that asbestos, including such dangerous varieties as the blue asbestos, was widespread in the debris. As one Associated Press reporter observed in April, 1 month after the disaster, workers, volunteers, and residents roam freely through the debris. Some wear masks, others don't, despite the plumes of dust that shoot up every time a giant steel claw grabs a load of debris. On windy days, particles swirl in the air. They sting eyes and irritate throats before leaving behind a thin layer of dust on whatever passes through. Saito Takuo, a Sendai attorney working on housing-related issues in the Northeast, said, quote, "There are a lot of people just going back into the rubble to search for valuables and photos. There are people that are not even wearing masks. This is like a suicidal act." Even 2 years after the disaster, observers continue to insist that the disposal of debris was incompetently handled. So far, observed Associated Press reporters, quote, "Disposal of debris from the disaster is turning out to have been anything but clean. Workers often lacking proper oversight, training, or proper equipment have dumped contaminated waste with scant regard for regulation or safety, as organized crime has infiltrated the cleanup process." Now this is kind of an important point. The one lesson that was learned from the Hanshin-Awaji tragedy was estimates, and they vary according to the Environment Ministry's website, but somewhere between 78 and a full 92% of the total cost of the cleanup was asbestos mitigation. So it might be an inexpensive building material, but it is very expensive to get rid of. As any of you that have done a home improvement project and you realize that underneath the carpet is asbestos tile, and you have to bring in proper people to work with it, it has raised the cost of your home improvement project considerably. It's very expensive to deal with, okay? So what's happened now is there's all kinds of accusations that the government is turning a blind eye and is letting organized crime in Japan sort of unofficially deal with a lot of the debris and just bury it in landfill sites, as opposed to take it to the 6 incinerators that actually exist that you can properly get rid of the stuff. And I'll talk about that in a minute, how that works. So the debris from the Great Eastern Japan earthquake contained large amounts of asbestos, as later air quality monitoring revealed. And all of these people were exposed to the dangerous fiber. So let me just go through with you, and this is kind of where the bulk of the research for this project has been up to this point. I went through and looked at the entirety of the Environment Ministry's record keeping on testing for asbestos levels. And again, I just show you what the city is, what kind of an area it was that the asbestos levels were, what the date was, and then how many fibers per liter were detected. And again, not unlike radiation, which persists for a long period of time in the environment. Of course, asbestos is very different, but it is just a rock, so it doesn't go anywhere. And what tends to happen is when they created these giant dumping sites where they were accumulating debris, the soil there has just been saturated in asbestos fibers. So one of the concerns is that every time the wind blows, every time something happens, it just kicks up all this asbestos dust because it continues to persist in the environment. One of the things I was most struck by when I traveled to Libby, Montana with this Japanese delegation was basically the city of Libby, Montana is being picked up by a giant earth remover and moved back to the W.R. Grace mine and buried. Houses, lawns, because the asbestos in Libby was in the vermiculite, and vermiculite was used in planting. So all of the lawns are being picked up, just dump truck upon dump truck upon dump truck, hundreds of them, taking houses and lawns and schools, the top of a baseball diamond, around the high school track. All of this stuff was covered with asbestos. I had a conversation with a woman when I was there who was telling the story. You know, she kind of picked up immediately that I wasn't from Libby, asked me what I was doing there, sort of guessed it was related to asbestos. And she told this story where when she was a little girl, her father every year for Halloween would dress her up like a princess and take vermiculite and then crush it over her because it's very colorful and beautiful, and so it was fairy dust. So, I mean, that's how saturated some of these areas can be in it. It's very hard to get rid of. So these are examples of asbestos that I was able to find of the amount that's detected. As you might expect, the Japanese government has been very thorough in trying to catalog, for the purposes of protecting workers eventually, what sort of asbestos products were here. This is just an example. This is a kind of drywall, but why it got my attention is it's a kind of tremolite-based asbestos. Tremolite is actually pretty rare in the world, and most of it came from Libby, Montana. So this is probably tremolite asbestos from Libby. Tremolite is very, very needle-like and considered to be very dangerous. And we can talk about this a little bit, but not all asbestos-formed minerals are created equal. And a lot of them actually have chemical compositions that are toxic. It's not just that they pierce tissue, but they actually have chemical compositions that are dangerous as well, right? So the different kinds of asbestos are very important to identify. You have a lot of aerial photography, you have a lot of photography on the ground, the government identifying all of these buildings had to be demolished. All of them contained asbestos slate. That kind of, it looks like a kind of a corrugated cement roofing tile. Is ubiquitous in Japan. It's just simply ubiquitous, it's everywhere. This is what the sniffing stations look like. You'll have a variety of these kinds of sniffers that they'll set up that are connected to a guy or a series of researchers that would be in these vans, trying to monitor as the cleanup is progressing if they're releasing lots of ambient levels of asbestos while they're doing the work, because they're very concerned about it. Obviously, the government officials are concerned about it because they're in hazmat suits. And then this is the kind of thing that they would discover. You know, there's lots of particulates, there's lots of dust, but I think that image gives you some sense of why asbestos is particularly worrisome, right? You don't want to get a lot of those in your lungs. So fairly early on, an adjustment was made to try to protect workers. A lot of the volunteers and stuff were kind of handed these Home Depot dust masks that you might get for sweeping your garage. If I was arriving, I think that would be unsatisfactory for me. I would want a much more serious respirator than that. And they eventually did make that transition in a lot of workers. But again, we're talking months afterwards. Workers involved with the cleanup were given proper respirators to begin the work. Just to give you a sense of why the cleanup can be so expensive, you have an example here of these kind of assembly lines, where people are going through and trying to, in stuff that's suspected of containing asbestos, trying to divide it out from regular debris so that it can be brought to certain kinds of facilities. So, I mean, we're talking about a lot of debris from this earthquake, right? So this kind of intensive approach would be astronomically expensive, which gives you some sense of why organized crime has got involved with the cleanup process. So let me just end by saying this. With the average human lungs able to take 4 to 6 liters of air per breath, 4 to 6 liters of air per breath, and the average human body taking in about 20,000 breaths of air daily while resting, even trace amounts of asbestos could accumulate and cause future health problems for workers. Right? If you're taking 20,000 of these in a day, and 4 liters in a breath, and there's 13 fibers per liter, the chances of getting exposure are actually quite high. Though governments often set legal limits for asbestos in ambient air, not in Japan and the United States, thankfully, the scientific community as well as the US EPA agrees that asbestos causes cancer and that there are no safe levels of exposure, none. Even chrysotile asbestos, which a handful of nations, including Canada and Russia, continue to mine and export to developing countries, but even these cause asbestos, cancer, as well as a variety of other pulmonary diseases. Laryngeal cancer, and possibly now ovarian cancer, gastrointestinal cancer, and colon cancer. With the possibility that tens of thousands of dangerous fibers were inhaled by first responders, volunteers, and relief workers each day, the future health threats of asbestos exposure after the Great Eastern Japan earthquake may even outweigh the future risks caused by radiation at the Fukushima Daiichi reactor. Like all asbestos exposure, only time will tell, which is where the historian's analysis, unfortunately, must end. So, thank you.